In this video, we'll be looking at some solved examples on exponential equations leading to quadratic equation. And so if you have not subscribed to this channel, kindly subscribe for more updates. Let's get started. So in our first example, it says that what is the value of x if 2 exponent 2x minus 5 multiplied by 2 exponent x plus 4 is equal to 0. And so with this, we have our question as 2 exponent 2x minus 5 multiplied by 2 exponent x plus 4, which is equal to 0. And so with this one, we are saying we want to look for a common base and a common exponent, and then we equate this common base and common exponent to a preferred variable. And so we can see 2 exponent x and 2 exponent 2x, which means we can express 2 exponent 2x as 2 exponent x. So if that happens, then we have 2 exponent x all exponent 2. And basically, when we multiply the exponents, we are going to get back 2x. That is 2 exponent 2x. We have minus 5 and 2 exponent 2x plus 4, which is equal to 0. And so we have the common base and common exponents. And so with this, we can equate them to a preferred variable. So we are choosing y to be our preferred variable. So which means let y be equal to 2 exponent x. So in place of 2 exponent x, we are going to substitute y. So we have y squared minus 5y plus 4, which is equal to 0. Now, having known this, then we have a quadratic equation. And so when we take the coefficient of the term y squared, we multiply by the constant term 4, and we are going to look for the factors of 4, that when we add, we are going to get minus 5, and when we multiply, we are going to get positive 4. And so the factors are minus 1 and minus 4. And so we can write our factorized terms as y minus 1 multiplied by y minus 4, which is equal to 0. And so at this point, we can find the value of y, which means when y minus 1 is equal to 0, we have our y value here to be 1. In the same way, when y minus 4 is equal to 0, then our y value there is equal to 4. And so these are the values of y. But we are interested in finding the values of x. So if that happens, remember that we said that we should let y, but we said we should let y be equal to 2 exponent x. So if now we are saying that y is equal to 1, then what do you think be the value of x? So in place of y here, we are going to put 1 there. So we have 1 is equal to 2 exponent x. Now in indices, remember that any number of an exponent of 0 is equal to 1. So which means we have 2 exponent 2x here. Now that the base are the same, then we can see s is equal to 0. We simply equate the exponents. Now, in the same way, when y is equal to 4, then we are going to substitute the value of y in y is equal to 2 exponent x, which means we have 4 to be equal to 2 exponent x. And at this point, we can express 4 as 2 exponent 2, which is equal to 2 exponent x. Now, since the base are the same, we equate the exponents, and thus we have s to be equal to 2. And so this becomes the values of x, and that is what we are interested in. So therefore, we can say that x is equal to 0 and x is equal to 2. So these are the values of x. Now let's go to the next question. And question 2, it says that given 10 exponent x minus 4 multiplied by 10 exponent x, which is equal to 3, find the value of x. And so we have our question as 10 exponent x minus 4 multiplied by 10 exponent minus x, which is equal to 3. Now, when we find the value of x, we first have to break this equation down. So though we can see 10 exponents x and 10 exponents minus x, and so we can equate them to a preferred variable. But wait, what is a exponent minus 1? In indices, we said that a exponent minus 1 can be written as 1 out of e. So if at this point we have 10 exponents minus x, then it means that we can write 10 exponents minus x as 1 out of 10 exponent x. So which means this 10 exponent minus x can be expressed as 1 out of 10 exponent x. And so we have this basic idea, then we can continue with our solution. And so in place of 10 exponent minus x, we write 1 out of 10 exponent x. So we have here as 10 exponent x minus 4 multiplied by 1 out of 10 exponent x, which is equal to 3. Now we have 10 exponent x here and 10 exponent x here, so we can equate them to a preferred variable, and we are choosing y. So let y be equal to 10 exponent x, which means that we are going to put y wherever we see 10 exponent x, and we have y minus 4 multiplied by 1 out of 4, sorry, 1 out of y, which is equal to 3. And so we have the least common multiple here, that is y. So you multiply through by y. So it means y multiplies y minus 4, and then we have 1 out of y multiplied by y, which is equal to 3 multiplied by y. And so at this point we have y squared, and we can see this y will cancel that y. So what is left? 4, which is equal to 3 times y gives us 3y. And so we can see a quadratic equation. So we can rearrange the equation to be of the form y squared. Now we send the 3y to the other hand side of the equation, that is the left hand side, and we have minus 3y minus 4, which is equal to 0. And so this is a clear quadratic equation, and we find the factors of the constant term. But before that, you have to multiply by the coefficient of the term y squared, that is 1, and 1 multiplies minus 4, we get minus 4. And so factors of minus 4, that when we add, we are going to get minus 3, and when we multiply, we're going to get minus 4. So we can think of 1 and minus 4, which means our factorized terms can be written as y plus 1 multiplied by y minus 4, which is equal to 0. So at this point, we can see that when y plus 1 is equal to 0, now y value here is equal to minus 1. In the same way, when y minus 4 is equal to 0, then our y value here is equal to 4. Now we are interested in finding x. So remember, we said that we should let y be equal to 10 exponent x, which means wherever we see y value, we are going to put into this equation. So we said for y equals to minus 1, then let's take it back. So we said for y is equal to minus 1, then our y value, so our x value for this is minus 1 to be equal to 10 exponent x. Now we said in indices that when we are looking for the value of x and the other term happens to be minus, since x cannot be negative, it implies that minus 1 is not equal to 10 exponent x, which means that for all values of x, we are saying 10 exponent x should be greater than 0. So which means we are looking for positive numbers for 10 exponent x or x. So it means minus 1 cannot be equal to 0. So we have one of the roots of the quadratic equation to be negative. It means there's no solution to that particular root of the quadratic equation. And that's what is leading us to get the value of x not to be defined here. So we go to the next one, and the next one we said for y is equal to 4, then means we have 4 to be equal to 10 exponent x. Now in this instance, we cannot express 4 for it to have a base of 10. So what you can do is that we have to take log of both sides, which means we have logarithm of 4 to the base 10, which is equal to logarithm of 10 exponent x to the base 10. Now what do we see? We can express 10 exponent x to the base 10 as, so we write our logarithm of 4 to the base 10, which is equal to, we bring the x here to the left hand side of the logarithm, and we have x log 10 base 10. And we know in logarithm that a logarithm of the same base and the same number is equal to 1. So which means logarithm of 4 to the base 10 maintained, we have x. So this was going to give us 1. You have a logarithm of the same number to the same base is equal to 1. So we have 1 here. And so at this point, we can see that our x value here is equal to log 4. And on our calculator, the value of log 4 is equal to 4 decimal place 0.6021. So this is to tell us that the only value for x is equal to 0.6021, and so this becomes the value of x to this equation. Now let's go to the next set of questions, and with that one we have in example 3, it says that if 4 exponent x minus 3 times 2 exponent x plus 1, which is equal to minus 8, find the value of x. So simply we have our question as 4 exponent x minus 3 times 2 all exponents x plus 1, which is equal to minus 8, and we are interested in finding the value of x. Now at this point we have to look for common base and common exponents, and then we equate them to a preferred variable, which means that we can simplify 4 exponent x as 2 exponent 2 all exponents x, because 2 exponent 2 is giving us 4, and our existing x is what we have written here. So minus 3 multiplied by, now in indices we have the exponents being added as x plus 1, which means that originally the bases were multiplying. So just like we have written here, so if the bases are the same and then they are multiplying, we go ahead and add the exponents. So the result of the adding the exponent is what is being given as the question. So we have to express these 2 exponents x plus 1 as the original question as 2 exponent x times 2 exponent 1. So this is what we have, which is equal to minus 8. Now having known this, we can see that we can go ahead and express 2 exponent 2 all exponent x as 2 exponent x all exponent 2 minus 3. So at this point we can put them in brackets, so 2 exponent x, and we know 2 exponent 1 is the same as 2, so minus 8. So having known this, we have 2 exponent x and 2 exponent x, so we can say that let y be equal to 2 exponent x. So now we have y squared minus 3, and we have 2 exponents x here, which means we are going to put y there. So we have y here times 2. This is the times 2, which is equal to minus 8. And so what next? At this point we can see that we can simplify this, and we have y squared minus, now 3 multiplies 2, we have 6, and then there is y here, so 6y, which is equal to minus 8. And so we can rearrange this, and then we have y squared minus 6y plus 8, which is equal to 0. And so this is a quadratic equation, and as usual we have to multiply the term, the coefficient of the term y squared, by the constant term, that is 8, and then look for their factors. So factors of 8, that when we add we are going to get minus 6, and when we multiply we're going to get 8. So that means we can consider 4 and minus 2, and so we can write our factorized terms as y minus 4 and y minus 2, which is equal to 0. And so when y minus 4 is equal to 0, our y value here is equal to 4. In the same way, when y minus 2 is equal to 0, our y value here is equal to 2. And so we are interested in finding the value of x, but remember that we said we should let y be equal to 2 exponent x. So in place of y we are going to put 4 there. So for y is equal to 4, then we have here as 4 to be equal to 2 exponent x. So we know 4 can be expressed as 2 exponent 2, which is equal to 2 exponent x. Now since the bases are the same, we equate the exponent, and thus we have s to be equal to 0. In the same way, when we come here for y is equal to 2, then we have 2 to be equal to 2 exponent x. Now this 2 has an exponent of 1, so we can see that the bases are the same, which means x is equal to 1. So therefore we can say that s is equal to 2 and s is equal to 1. And so this becomes the value of x. Now let's look at the next question, and we have determine the value of x from the equation 3 exponent 2 multiplied by 1 plus x minus 3 exponent x, which is equal to 3 exponent x plus 3 minus 3. So with this, our question is saying that we have 3 exponents to 1 plus x minus 3 exponent x, which is equal to 3 exponent x plus 3 minus 3. And so with this, we are looking for a common base and a common exponent to equate them to a preferred variable. Now what can we see? We can expand the exponent here, and we have 3 exponent 2 plus 2x minus 3 exponent x is equal to 3 exponent x plus 3 minus 3. And so we can see that, let's erase this and make it nice. So we have x plus here. So now we can see that they have a common base, and then they have this base has an exponent of 2 plus 2x, which means that originally it was written as 3 exponent 2 times 3 exponent 2x. And so the idea was that the base are the same, and so they added the exponent. And so the reverse form of this is what we have written here. So minus 3x, which is equal to, so in the same way, the exponents are multiplying, they are adding, the exponents are adding. So it means that the base are originally multiplying, which means we have 3 exponent x times 3 exponent 3 minus 3. And so having broken it down like this, then we can further simplify our solution as 3 exponent 2 times, now 3 exponent 2x can be written as 3 exponent x, then we bring our exponent of 2 minus 3 exponent x, which is equal to 3 exponent x, and then we have here as 3 exponent 3 minus 3. I know there are a lot of 3's, but if we follow and we are consistent with it, we can be able to differentiate the 3's. Now we are saying that we have a common base and exponent here, common base and exponent, common base and exponent. And so we can say that we should let y be equal to this common base and exponent. And so we have 3 exponent 2 times y exponent 2 minus y, which is equal to y times 3 exponent 3 minus 3. And so with this, we can see that 3 squared is giving us 9, and it's being multiplied by y squared. And then the next one, we have y here, and then we have y. Now we know 3 exponent 3 is 27, so which means it's being multiplied by 27, and then we have minus 3 here. So at this point, we have 9 squared and minus y, and then we have 27y minus 3. So to break it down further, then we can say quadratic equation, and so we can rearrange them. So basically like grouping like them. So we have y squared minus y. Now this is positive 27, so you cross the equal sign, you have minus 27y, which is plus 3. So this negative 3 cross the equal sign becomes positive, and you have 0 here. So at this point, we have 9y squared minus 28y plus 3, which is equal to 0. And so this is a standard version of the quadratic equation. And so now we can see the coefficient of the term y squared is 9, and the constant term is 3. And so when we multiply these two, 9 times 3, we get 27. And so factors of 27, that when we add, we are going to get minus 28, and when we multiply, we are going to get 27. So at this point, we can consider minus 1 and minus 27. So now we have 9 squared. Now at this point, you see the coefficient of the term y squared is 9 and not 1. If it was supposed to be 1, we would have written it as such, just like you can see here. But since it's not 1 and it's 9, we have to break it down. So at this point, we have 9y squared minus y, that is the y is corresponding to minus 1. So minus 1 times y is the same as y. And then we have here as minus 27y, that is this 27, and we have our plus 3 here, which is equal to 0. and so we can put them in brackets, and we have 9y squared minus y, that is plus, so we have minus 27y, and then we have plus 3 here, which is equal to 0. And so at this point we can factorize the common term out, so that is why y is common here, so which means we have y out, and we have 9y here and minus 1. So when y multiplies whatever is in the bracket, we get back the original term. So plus, now the common term here is 3, and so 3 out, and when 3 multiplies 9, we are going to get back this minus 27. But before that, we can see that the term here is minus 27, which means that this 3 must be negative, and so we have minus 3 here. So minus 3 times 9y gives us the negative 27. Now we continue, and at this point we can see that when we write minus 1 here, we can get back our positive 3. That is minus 3 times minus 1, giving us positive 3. So we continue, and you can see that there is a common term here, 9y minus 1, 9y minus 1. So we write them as one term, and we add the term outside. So at this point we have 9 minus 3 as one term, and we have 9y minus 1 as one term, which is equal to 0. So these are the factorized terms. So when y minus 3 is equal to 0, then our y value here is equal to 3. In the same way, when 9y minus 1 is equal to 0, we have 9y to be equal to positive 1, and in find the value of y, we have 9y is equal to 1, and so we divide here by 9, we divide here by 9, and so y here is equal to 1 out of 9. Now these are the values for y, but we are not interested in finding the value of y. We are interested in finding the value of x. But remember, we said we should let y be equal to 3 exponent x. So for y to be equal to 3, then our x value is nothing but 3, which is equal to 3 exponent x, and we can see 3 has an exponent of 1 and is equal to 3 exponents x. And so since the bases are the same, then we can see that x is equal to 1. Now let's come to the other side. That is for y to be equal to 1 out of 9. We are saying that in place of y, we are going to put 1 out of 9 there, which is equal to 3 exponents x. Now 1 out of 9 can be written as 9 exponents minus 1, and is equal to 3 exponents x. And so 9 exponents minus 1 is the same as 3 exponent 2 all exponents minus 1, because 3 exponent 2 is going to give us 9, which is equal to 3 exponents x. So having known this, then we can say that we can write this as 3 exponents minus 2, and that is when we are trying to multiply the exponents. So 3 exponents minus 2, so which is equal to 3 exponents x. And so we can see that the bases are the same now, and so we can see s is equal to minus 2. And so therefore we can say that x is equal to 1, or s is equal to negative 2. And so this becomes the value of x in this equation. So this ends today's video. Thanks for watching. Kindly like, comment, subscribe, and share. See you in our next video. Bakumat, thinking beyond infinity.